Okay, so here are the answers to the practice exercises in our um, discussions last time. So for the first one, we have here a researcher wants to test a claim that the mean cost of tuition fees at a four-year public college is greater than 5,700 pesos. He selects a random sample of 36 public colleges and finds the mean to be 5,950 pesos. If the population standard deviation is 659 pesos, is there enough evidence to support the claim at an alpha of 0.05? So again, what do we have here? We have here a population mean of 5,700 and a sample mean of 5,950. The given population standard deviation is 659. So let's start off with the first step, which is to identify the hypothesis. The null hypothesis always states that there is no significant difference between the uh, two means that are being compared. So for this case, the population mean of 5,700 and the sample mean of 5,950. So therefore, the mu is equal to 5,700. And for the alternate hypothesis, since the alternate hypothesis always states that there is a significant difference between the groups being compared. So specifically for this problem, there is a claim that the researcher claims that the mean cost of tuition fees at the public college is greater than 5,700. So we can say that the average tuition is greater than 5,700. That is, if there is a significant difference between the population mean and the sample mean. Thus, mu must be greater than 5,700. Okay, so that will be our hypothesis. So next step, the given alpha is 0.05. And this is a one-tailed test, specifically a right-tailed test, because the claim is greater than the population mean. So if it's greater than, then we use right-tailed test. So for the formula Z, so this is a Z test, a one sample Z test to be exact, because we are comparing the population mean and the sample mean plus the population standard deviation is given. So we use the one sample Z test. So we plug in the given. So the sample mean is 5,950 minus the population mean of 5,700 over the population standard deviation is 659 over the square root of the sample size, which is 36. So overall, the Z test value is 2.28. And then we identify the critical region using the Z table that we have. For a one-tailed test with the 0.05 alpha, so the critical region will be positive 1.65. So we use positive because we are using a right-tailed test or one-tailed right-tailed test. So the critical region will be on the right side of the curve. So the red one with the shaded part to the right. And then we plot the Z test value, which is 2.28. So which is clearly inside the rejection region. So since the test value is inside the rejection region, we reject the null hypothesis. Therefore, if we reject the null hypothesis, there is enough evidence to support the claim that the mean cost of tuition fees at a four-year public college is greater than 5,700. All right. So for the next item, so we have here a teacher at a college claims that the students in the college have above average intelligence. A random sample of 30 students, IQ scores have a mean score of 112.5. Is there a sufficient evidence to support the principal's claim? So the mean population IQ is 100 with a standard deviation of 15. Use alpha of 0.05. So again, the situation is comparing the population mean of 100 and the sample mean of the college to be 112.5. So the null hypothesis again, there is no significant difference between the population mean, which is 100, and the sample mean of 112.5. Mu is equal to 100. So H1 or the alternate hypothesis states that the average IQ in the college is higher than 100 because that is a claim of the college the teacher at the college. So if there is a significant difference between the sample mean and the population mean, then we can say that the average IQ in the college is higher than 100. So mu is greater than 100. So second step is identify, of course, the given alpha is 0.05. And still we are using one-tailed test because the claim is greater than the mean or the population mean. So that means it's a right-tailed test. So again, we are using a one sample z-test because the population standard deviation is also given. So we plug in the given values. So the sample mean is 112.5 minus the population mean of 100 divided by population standard deviation of 15 over square root of 30, which is the sample size. Thus, the value or the test value is 4.56. And then we identify the critical region, again, using the z-table for the one-tailed test with alpha of 0.05. The critical region is 1.65. And again, we use positive because this is a right-tailed test. So we plot the critical region with the red marks here. And we plot the test value, which is the blue one. Z is 4.56. So I put it at the edge of the graph. So since it's 4.56. So since the test value is inside the rejection region, we reject the HO. Therefore, there is enough evidence to support the claim that the students in the college have above average intelligence, meaning the 112.5 is significantly different than the 100 population mean. The next, we have here the level of blood glucose for obese patients have a mean of 100 with a standard deviation of 15. Researcher thinks that high in raw cornstarch diet will have either a positive or negative effect on the blood glucose levels. So a sample of 30 patients who have tried the raw cornstarch diet had a mean glucose level of 140. Test the hypothesis that the raw cornstarch had an effect. Use alpha 0.05. So HO, there's no significant difference between the population mean of 100 and the sample mean of 140. So mu is equal to 100. H1, again, there is a significant difference in the blood glucose level, which makes mu not equal to 100. So why are we simply saying that there is significant difference? Because the problem states that those people in the raw cornstarch diet will have either a positive or negative effect. So there's no specific direction, whether it will be greater than or less than. So we use the not equal symbol. Okay. So alpha again is 0.05. Now it becomes a two-tailed test because we use the not equal symbol, or since there is no specific direction of less than or greater than in the problem, so we use a two-tailed test. So again, this is a one sample Z test. Okay. Sample mean is 140 minus the population mean of 100 divided by population standard deviation of 15 over square root of 30, which is the sample size. So therefore, the test value is 14.61. The critical region is plus or minus 1.96. Why is it plus or minus? Since we are using two-tailed test, so it's both ends of the curve. It's on both ends of the curve, so positive and negative. So we have here the red marks, left and right. Okay, 1.96. So approximate na yung position of the 1.96. And then we plot the 14.61, which is towards the end part of the curve. So 14.61. All right, since the test value is again inside the rejection region, we reject HO. Therefore, the raw cornstarch diet had an effect since we reject the null hypothesis. Therefore, there is a significant difference between 140 and 100. Thus, the raw cornstarch diet had an effect. Okay, next item. So the average local cell phone call length was reported to be 2.27 minutes. A random sample of 20 phone calls showed an average of 2.98 minutes in length with a standard deviation of 0.98 minutes. At an alpha of 0.05, can it be concluded that the average differs from the population average? So this average pertains to the sample average of the 20 phone calls. So therefore, HO, or the null hypothesis, there is no significant difference between the population mean of 2.27 and the sample mean of 2.98. Mu is equal to, that should be 2.27. And H1, or the alternate hypothesis, there is a significant difference in the average cell phone call length, which gives us mu is not equal to 2.27. Since there is no claim in the problem that the average call length is either less than or greater than, so there's no specific direction. So it just asks that, can it be concluded that the average differs from the population average? So that's what we're looking for, if there is a significant difference. Okay. Next, so alpha is 0.05. Again, it's two-tailed test because there's no specific direction of less than or greater than. And now we are using one sample t-test. Why? Because there is no population standard deviation given. So we are now using a sample standard deviation. So the mean, sample mean is 2.98 minus population mean of 2.27, and the sample standard deviation is 0.98 over square root of n, which is the sample size, which is 20. Thus, the t-test value is 3.24. With the critical region, using the t-table, since for the t-table, we need the df, or the degrees of freedom. So the degrees of freedom will be n minus 1, that's 20, minus 1, that's 19, with an alpha of 0.05 and a two-tailed test. The critical region is 2.09, and we are using plus or minus since it is two-tailed. The shaded region, or the critical region, or the rejection region will be on both ends of the graph. So their approximate position of the 2.09 on both ends of the graph. Okay, then we plot the t-test value, which that should be t, 3.24. So again, it's towards the end part of the graph. Okay, since the test value is inside the rejection region, we reject HO. Therefore, the sample average cell phone calls differ from the population average. So there is a significant difference between 2.98 and 2.27. Next item. So researcher wants to test if there is a significant difference between the grades of students from two different universities, University A and University B, taking up the same course. The data are as follows. So for University A, we have here 88, 87, 79, and so on until 83, 81, 98. While for University B, these are the grades 87, 89, 85, and so on until 79, 80, and 90. So since we are given raw scores for two different groups, and of course, these are just samples, okay, from the two universities. We have here 29 samples from University A and 29 samples from University B. So use your knowledge of getting the mean and the standard deviation of these two samples. You may use the Excel from our previous discussions to solve for the mean and the sample standard deviation, because we are using samples from the two universities. So sample standard deviations will be computed. So we start with the HO, or the null hypothesis. There is no significant difference between the grades of students from University A and University B. So mu1 is equal to mu2. And the alternate hypothesis, there is a significant difference between the grades of students from University A and University B. Therefore, mu1 is not equal to mu2. So we are comparing here the grades of University A and University B students. Then we need to solve for the mean the sample mean 1, that will be for University A, and the sample mean 2 will be for University B. So for University A, we have 87.17 for the sample mean, and the sample standard deviation is 6.25. And for the sample mean for University B, that's 86.48, and the standard deviation of 5.87. So we are comparing these two means, 87.17 versus 86.48. So alpha is 0.05. So since alpha is not given in the problem, we use 0.05 as discussed from our class. So if the alpha is not given, we use 0.05. So this is a two-tailed test because there's no specific direction to which of the two universities is seen to be better or seen to have higher grades or lower grades. So the problem only states that to check, we need to check if there is a significant difference between the two. Okay, so the formula for the two sample or independent samples t-test. So we have here sample mean 1 minus sample mean 2 minus population mean 1 minus population mean 2, which will be canceled later on because they are equal, so that will be 0. So divided by the square root of the sum of sample standard deviation squared over sample size 1 plus sample standard deviation 2 squared over sample size 2. So we plug in the details. 87.17 is for x sub 1, meaning the sample mean of University A minus the sample mean of University B, which is 86.48, divided by the square root of S1 is sample standard deviation of University A, which is 6.25 squared, divided by the sample size, which is 29, plus 5.87 is the sample standard deviation of University B squared, divided by 29, which is the sample size. And this gives us the value or the t-test value of 0.39. The critical region for this is 2.05. How did we get this? We use the t-table. So we use degrees of freedom of 28. That's from 29 minus 1, so we get 28. And alpha of 0.05 in a two-tailed test, so 2.05. And we use plus and minus since this is a two-tailed test. So the graph here, 2.05 is plotted here on both ends. Again, it's at an approximate position. So the z or the t test value, this should be t. Sorry for that. That should be t. And it's 0.39, so it's close to 0. So since the test value is outside the rejection region, we do not reject HO. Therefore, there is no significant difference between the grades of students from University A and University B.